Delmy says hi. Good. Today we have for which values of z 15z plus 2 on 5z minus 3 is an integer. Now we know that integers are all negative and positive values. So that means that we need to find the values of z that will make our expression here a negative number or a positive whole number. A negative whole number or a positive whole number. Good. So, first of all, we introduce a variable p. So we have let's 15z plus 2 on 5z minus 3 equals to a particular variable p. So a particular number p. So to easily solve this, I would suggest we'll make the denominator similar to the numerator. I'm using the denominator because the coefficient of the variable here is smaller than that of the coefficient on top here. So I'm using the smaller one to meet the bigger one. So here we have here, this is 5 and this is 15. So in order for the 5 to be equal to the 15, we need to multiply, yes, by 3. So we'll be having, this implies, since it's an equation, whatever you do to the left hand side, you must do to the right hand side. So you multiply by 1/3. So we have 1/3 multiply 15z plus 2 on 5z minus 3 equals 1/3 of p. So we'll be having, this implies, solving this, you have 15z plus 2 on, here will be 15z, then 3 times 3, that will be 9. Okay, so equals 1/3 of p. Good. So the next thing is we make the numerator now the same as the denominator, since the denominator is the divisor. So in order for this to easily divide this, we try to make this the same as the denominator. Now you have here 15z plus 2, but here it's not plus 2, this is minus 9. So we have to find a way of bringing the minus 9 here. So we use an identity, because there's nothing we can do to the numerator. Okay, there's nothing we can do to the numerator which will not change the whole expression. So we do not want the expression to change. So if you do not want the expression to change, we have to use an identity. So we introduce a 0, since the identity we want to use is an additive identity. So we introduce a 0 because this is negative 9. Okay, it's not a multiplier. So that means we introduce the identity using the negative 9. So this implies that 15z plus 2. Now this is what you're introducing, so minus 9. Now when you introduce the minus 9, we need to negate the minus 9. So we have plus 9, so that we eliminate it. So we have 15z minus 9 equals 1/3 of p. So we can now bring terms together so that it looks like, so the part looks like the denominator. So we have 15z minus 9, then plus 2. So you have 2 plus 9, which will be 11. So on 15z minus 9 equals 1/3 p. So you have, this implies that, so now we can now separate, so we can part the fraction. So you have something like partial fraction. So you have 15z minus 9 on 15z minus 9, then plus 11 on 15z minus 9. Okay, so, but note that our particular number is equals 1/3 p, 1/3 of p. Now you remember that our particular number, that is the p, okay, the p should be an integer. So this p should be an integer. So if it should be an integer, that means that we are supposed to clear this fractional multiplier. Okay, so we multiply through, in order to clear the 1/3, we multiply through by 3. So since it's an equation, whatever we do to the right hand side affect the left hand side. Multiply here by 3, multiply here by 3. So we'll be having 3 times 15z minus 9 on 15z minus 9 plus 11 on 15z minus 9 equals 3 times 1/3 of p, so that it clears off. So you'll be having, here will be, this implies that here becomes 1, so you have 3 times 1, 3. Then plus, you have 3 times this, you have 33. 33 on 15z minus 9 equals p. So we have our p back. Now, this is an integer, but this might be an integer or might not be, depending on the expression we give to the denominator. So in that case, we apply the closure property, and we know that the closure property says that for integers plus integers will always give you an integer, and that is a fact. So if integer plus integer gives us always an integer, that means that this, we do not worry about this, we just worry about this. So we have this. This means that the denominator should be a factor of the 33, so that we get a whole number here, or an integer here, which can be added to this to get another integer. So for 15z minus 9 to be a factor of 33, we know that the factors of 33 are 1, 3, 11, and 33. So that means we equate the 15z minus 9 to all this, and that will give us the value of z. And that's all.